back, y'all. Here we are today. We're going to continue with properties of logarithms video number 2. And we're going to look at properties of logarithms again. This time, we're going to be condensing and using these properties to rewrite expressions that have more than one log into an expression with only one log. This is going to be extremely helpful in the future. So let's look at these examples here. I'm going to quickly review our properties. Our properties basically were told us, and they were on the previous video, but I'm going to quickly review those. If I have log base b of m plus log base b of n, I can rewrite that as log base b of m times n. So basically, if I have a plus, I can rewrite it as a multiplication, or vice versa. So that's one rule. The second one was the opposite. If I have log base b of m minus log base b of n, I can write that as log base b of m divided by n. So again, I have division. I can rewrite as subtraction, or subtraction as division. And then the third one that we talk about, if I have log base b of m raised to the nth power, then I can write that as n times log base b of m. Okay, and that takes the number out of the exponent and allows it to become a coefficient, which is much more easy to deal with. So those are the three basic properties that we're going to be using right now. There was a fourth property we discussed that we can talk about later, but we'll just mention it again, that said log base b of m equals log base b of n, and this means that m equals n, that we get to drop the logs in this situation and just have m equal n. We'll talk more about that one later. Okay, so let's get to this first one. We have an addition, and our addition can be rewritten as a multiplication. These are log base e's. I want you to know I recognize that. And I can rewrite that as log base e of 9 times x, also known as just 9x, which again would just be natural log of 9x. I could do that in less steps, but I wanted you to see that. Example F is log base 10 of 3x plus 1 minus log base 10 of x. And so using my property, minus can be written as a fraction. So this one, definitely did not give myself enough room on this. This one can be rewritten as log base 10 of a fraction, where you have 3x plus 1 on top and x on the bottom. Okay, let me go over that one again, because I didn't give myself enough room. So this would be log base 10, with a little 10 there, and a little 10 there, there we go, of 3x plus 1 over x. And again, if you were to type it in the computer, it would say you don't need that 10. They would just do it like that. But we went from a subtraction to a division. Okay? G, all right, this one's got two things we're going to be able to do. We're going to take the 13 and move it, and then we're going to do the add. So again, this is log base 10, so we'll sneak it in there so everybody knows it's log base 10. So this will be log base 10 of y times z to the 13th. See, I can take that 13 right there. Also known as just log yz to the 13th. I know it's getting tricky, isn't it? All right, let's look at this next one. I've I've got an add. Add means I can put these two together using multiply. I gave myself enough room here. I can actually multiply those three together, those two things together. Well, should I actually FOIL that? Yes, let's go ahead and FOIL that. 4x squared plus 12x minus 5x be plus 7x minus 2. And that's all we can do, but we have condensed it. We took an expression with 2 logs and condensed it to an expression with 1 log. Last one, we're going to do the powers first. Each one of these coefficients can go up. Each one of those coefficients can go up. And so that's going to be a natural log of x to the third plus natural log of y to the second minus natural log of z to the sixth. Now we'll use our plus rule, our minus rule. Our plus rule says that this is natural log of x to the third y to the second. Our minus rule makes it a divide z to the sixth.